The MCAT Podcast, session number 106. A collaboration between the medical school headquarters and Next Step Test Prep, the MCAT Podcast is here to make sure you have the information you need to succeed on your MCAT test day. We all know that the MCAT is one of the biggest hurdles you'll face as a pre-med, and we're here to give you the motivation and information that you need to know to help you get the score you deserve so you can one day call yourself a physician. Welcome to the MCAT Podcast. My name is Dr. Ryan Gray, and as always, I am joined by Brian Snedeker from Next Step Test Prep, and we are going to jump in and continue our full-length 10 breakdown. All right, Brian, back with some more Next Step full-length 10. Last week, we had some discretes. This week, back with another passage before we wrap up with our final set of discrete questions. What's our passage about today?
So we're going to be doing passage number 9, which is largely biochemistry-ish passage, which, of course, our erudite listeners know. Biochemistry, very, very important in all the science sections, in the hard science sections, and that as far as the new MCAT is concerned, there are 3 biggies, right? First, biology, second, psychology, third, biochemistry, right? Like if you were going to focus your efforts anywhere, those are the big 3. We're on passage 9, but this is the last one we're going to do. Passage 10 doesn't really work well on a podcast because it's all visual graphs and stuff. So as always, I'm just actually going to read a selection from the passage. I'm just going to read the 2 paragraphs in the middle, and then we'll answer some questions based on that. So we've got drug X is designed to assist the body with the rate-limiting step of glycogenolysis, right? Remember, glycogenolysis, breaking down glycogen. The drug molecule is 560 amino acids long and weighs 65 kilodaltons. The drug can exist as an inactive monomer, but is only pharmaceutically active as a dimer with 2 matching subunits. It's shown to be effective with glycogen, but not cellulose. Not a surprise, right? Humans don't eat cellulose. X-ray crystallography has identified 4 biologically significant sites on the active form: a catalytic site, an allosteric site, a glycogen site, and a phosphorylation site. Glycogen is bound at the glycogen site prior to the initiation of terminal glucose cleavage. So some of this is, information about drug X. Some of this should be kind of tickling the back of your brain, knowing about how glycogen is formed and broken down. That's all stuff we would walk into the test being comfortable with. We continue to read. Further analysis shows that the phosphorylation site and the allosteric site are used in vivo for the regulation of drug X's activity. For example, secretion of epinephrine, a potent vasoconstrictor, causes phosphorylation of the inactive monomer, transforming it into the active dimer. So once again, let's get that cause and effect clearly. Secretion of epinephrine phosphorylates the inactive monomer, transforming it to the active dimer. It is hypothesized that a single enzyme, phosphorylase kinase, PK, is responsible for this transformation. The proposed pathway is outlined in Figure 1. Structurally, PK is polymeric with 4 identical subunits. PK is activated by intracellular calcium levels. When calcium exceeds 10 to the minus 6 molar, PK binds calcium and is activated.
All right, so a lot to digest. So let's break into question 49 and see where we need to jump back and reread and relearn. So question 49, several attempts were made to isolate the active form of drug X from a tissue sample. All but one test failed to yield a pure extract. Based on the information presented in the passage, this successful test was due to A, excessive centrifugation speeds that cause the breakdown of drug PK, elevated pH levels that cause hydrolysis of peptide bonds in PK, C, calcium contamination that led to the phosphorylation of drug X monomer, or D, alcohol contamination that denatured the drug X monomer. So they want to know the successful test, and they were trying to isolate the active form of the drug. And while you were reading it, right, we had the cause and effect that you wanted to stress. So I'm going to go back to that part of the PK, or epinephrine rather, causing the phosphorylation of inactive monomer, transforming it into the active dimer. So that, to me, is the important part of the passage. Would I be correct going back there?
Yeah, well, it's absolutely the place we have to start, Ryan. And you were right that the question asks about successfully getting the active form. So that's the first question, just understanding the question. Like, what do they mean by active form of drug X? What did the passage say? And Ryan, you said it, that to be active, what has to happen to this drug?
That phosphorylation.
Got to get phosphorylated, right? So that was out of that first paragraph I read. We get, okay, active means phosphorylated. But then to get drug X phosphorylated, right, we were told in the second paragraph that what happens?
The calcium concentrations have to be high.
Yeah, so calcium activates PK, and PK phosphorylates drug X, right? It's like a 3-step process there.
Yeah, okay. So we need PK. We need PK after calcium concentrations are high. So let's go back to our answers here. Excessive centrifugation speeds that cause the breakdown of drug PK. That wouldn't make sense because we need PK. Right,
yeah,
so,
nothing about the centrifuge was anywhere here. Right?
Yeah. So I'd throw that out. Elevated pH levels that cause hydrolysis of peptide bonds in PK. Again, I don't think that would do anything.
Right. If you broke down the enzyme, you couldn't activate the drug.
Exactly. C, calcium contamination that led to the phosphorylation of the drug X monomer. I'm like, oh, okay, that sounds right. And then the D, just to check, alcohol contamination that denatured the drug X, and I wouldn't go there. So I think students would be thrown off potentially by the word contamination. Be like, wait a minute, what does that mean? I don't know if that's right, but I would go with that.
Yeah, well, and that's the thing is the question was unusual because it said all but one test failed. So what happened in the successful test? We're not used to the word contamination being associated with success, but that's exactly what happened. Is there was contamination that allowed us to successfully activate the drug and purify it. Yeah. Okay. Question number 50. Which of the following amino acids could a transaminase not possibly transform into a beta amino acid? So this is more of a kind of independent question associated with the science in the passage. And we didn't read the whole rest of the passage where it talked about different amino acids. So we've got answer choice A, ARG, B, PRO, pro, C, TYR, tier, D, GLY, gly. So obviously you have to know your 3-letter abbreviations for these various amino acids and which one could not possibly become a beta amino acid. So Ryan, what would you do here?
I would choose C because I had no clue, and I would choose C and move on.
There you go. Right, guess and go. Which it's always remind folks that you're battling several different demons on test day, and one of them is the clock. And so if you're thrown for a loop, you don't know, don't angst over it, don't spend a ton of time on it. Just pick and go. Here. When in doubt with amino acids, like if you're really truly lost and you have no idea, I always say when in doubt, go for proline, because proline is weird and different because its side chain connects back to its own amino group. And in that regard, proline is unique. It's not the right answer here. So my rule of thumb would get you the wrong answer. But but it's comforting to have those, right? Like it's comforting to have that, like, well, I don't know, but when in doubt, guess the liver, right? Because the liver does everything. When in doubt, guess proline. Good enough, right? In this case, the key to the question is knowing what a beta amino acid is. The biological amino acids are actually alpha amino acids. So to be a beta amino acid, you have to have one more carbon, right? You have to have a beta carbon. that is just one place over from the carbonyl carbon, right? So the alpha is the next door neighbor to carbonyl, beta is, two doors down. So in this case, to not possibly be physically capable of becoming a beta amino acid, you simply pick the amino acid that doesn't even have a beta carbon. And so in this case, the right answer is glycine, choice D, GLY, because glycine is the simplest amino acid. It doesn't have a side chain, or rather, its side chain is just a hydrogen atom. So because glycine doesn't even have a beta carbon, it cannot possibly be altered into a beta amino acid. So I will also add that, right, that rule of thumb on amino acids, if you have no idea what's going on, glycine is the other special one. It's the smallest, the simplest, it's the only achiral one. So when in doubt, guess proline or glycine. In one like this, where proline and glycine are both choices, flip a coin.
50-50. That's better than 25%.
They're exactly right. Yep.
Okay. Question 51. After administration of epinephrine, the radius of the abdominal aorta is cut by 1/3. According to Poiseuille's law, if the blood pressure is constant across the length of the vessel, blood flow through the abdominal aorta will A. Decrease to 2/3 to the fourth power of its previous value, B. Decrease to 1/3 to the fourth power of its previous value, C. Increase by 3/2 to the fourth power of its previous value, or D. Increase to 3 times its previous value. So we'd have to know Poiseuille's law and remember that. Blood pressure is constant across the length of the blood vessel. Blood flow through the abdominal aorta will, I would say, D. Increase by 3 if we're cutting the radius by 3.
Right. So, well, it says the radius of the aorta is cut by 1/3. So, if it was 30 centimeters, it's getting cut down to 20 centimeters. Right. So we're constricting the aorta. And when it comes to flow, you always want to flow through a fatter pipe, right? Like you want more room, whether it's current through a wire or water through a pipe. If you constrict down, much harder to have fluid flow. The real world example of this I always use is take one of those little tiny coffee stirrers and try to drink your soda through that. You can't, right? Because it's this tiny little radius.
Yeah.
So in this case, if we're cutting the aorta down, we're making it smaller, you're actually going to get less blood flow through it. So it's got to be A or B. Right, decreasing the blood flow.
Okay, I think I got stuck with the blood pressure.
Mm-hmm.
I didn't even finish the rest of the question. Blood flow through, right? The question about blood flow. Okay. Yeah.
Well, right. There's this weird thing that happens where technically, if you're going through a smaller pipe, you're going to be flowing faster, which actually means there's going to be less pressure, which is kind of like a physics answer, right?
Yeah.
But this is just bulk flow, like just how many red blood cells are you shoving through this thing every second, right? And if it's thinner, you're not getting as many through.
Okay.
Yeah. And in this case, it's ironic. You mentioned we have to know Poiseuille's law. We actually don't, because answer choices A and B are both to the fourth power. So they both tell us that whatever this equation is, the relationship between radius and blood flow is a fourth power. Sort of ironically, this question is actually just more an English language question. Like, what does cut by 1/3 mean? And it means, like the example I used, if you had a 30 centimeter radius, if you were cut by 1/3, you would go down to 20 centimeters.
Mm-hmm.
So to be cut by 1/3 means you are decreasing to 2/3 your original value.
Yeah.
Right. 30 down to 20 would be a 2/3 decrease. So that's answer choice A, right? It's 2/3. That's the new size. 2/3 the size of the original. And the fourth power, that must be how Poiseuille's law works.
Yeah. And it's funny you mentioned it's really just an English question, because the way that I originally read it was cut down from 30 to 10, right? It was cut to 1/3 of its previous value was the way that I originally read it.
Yeah, and it's funny you say that, because this is another one where, again, if you log into the Next Step test platform and look, and after you finish the test, you get to see little bar graphs of what everybody picks. And answer choice B decreased to 1/3 is like almost 35%, 40% of people pick that because they read incorrectly the same way you do.
Yeah.
So just again and again and again, it is a reading test. It is a critical thinking reading test. Read those questions super carefully, even when there's all these numbers in the answer choices.
All right, so there you have it. Some more Next Step full-length 10. Did you know, I always ask this in my Facebook group, the Pre-Med Hangout. If you're not part of the Hangout, you should be. It's medicalschoolhq.net/group. It's a group of almost 6,000 collaborative, amazing pre-med students. It's an amazing community there. And I ask every once in a while, I'm like, tell me what you think about full-length exams. Who are you using? What do you like? And inevitably, you get a lot of people that will go with the purple big box company because they have a lot of marketing. And then you'll have a lot of students that time and time again say Next Step. Next Step is the best. Next Step was the tests that were closest to the real MCAT that I took. Next Step scores approximated the best, the score that I got on my MCAT. Next Step full-length exams are by far the best out there, according to you guys, according to the students, right? I haven't taken the MCAT in a long time. So for me to evaluate, all I can look at is, do the questions look good? Is the platform nice? All that stuff, of course. Yes, definitely. But to simulate the real exam as it is now, I took it back on paper way back in the day. But right now, I rely on you guys, and you guys tell me Next Step full lengths are the best. So go check them out. nextsteptestprep.com. Use the promo code MCATPOD. That's all capital letters, MCATPOD, for 10% off those full-length exams. If you're in the market for other stuff as well, you can use that code and save some money on anything that Next Step has to offer. Hope you have a great week. We'll see you next time here on the MCAT Podcast.